Okay, hello everybody. Welcome to the first episode of Code for Teachers. So let's start with what this is about. I've been teaching computer science to students of middle school and high school ages for a number of years, and I really do believe that programming as a skill and as a tool is really powerful in learning, and it's missing from most of our classes. It would be to our students' benefit if they could use computational thinking and the tools of computer programming to explore math and science, but not just those, not just the STEM fields that we're used to, but also the humanities and really any other subject that they might encounter. The world is driven by technology now, and we want to give students the tools to understand it and manipulate it. But in order to do that deeply and appropriately, we have to master some of these skills ourselves as educators. So you might be asking, why should we teach programming generally as a non-computer science teacher? Computational literacy is important for understanding the world around us. So much of our life is generated by algorithm, and so much of our decision-making process is determined by technology that it might be useful if we could understand how those algorithms work and perhaps generate some of our own. The other part is computational thinking, not just understanding how systems work, but perhaps even being able to create them or solve problems inside of them. And we have to do that by reasoning about these systems. In a very real sense, programming is applied reason. It's kind of, in a way, pure logic. And that really excites me about it. And when you learn to program, it changes the way that you think. You become more analytical about things. You apply a process to understanding systems, even if they're not computational or not technological in nature. Programming is a medium. Code is a medium. And what that means is that once you learn how to use it, you can make new things with it. And when you're making new things, you are demonstrating learning. So by bringing computer programming into non-computer science courses, we open up a new universe of potential assessments, new exhibitions of mastery that our students can use to demonstrate, probably in a multidisciplinary way, their understanding of concepts. So let's talk about you. What kind of a teacher are you? What has brought you to this place? I'm making some assumptions here about your background so that we can create this content for a specific audience. So I'm going to assume that you're a K-12 teacher, that you're not a college professor, but you do work with students. And you've certainly been exposed to coding. Maybe you participated in an hour of code. Maybe you even do have some background. Maybe you've used Scratch, or maybe you've used some intro to code program like code.org. Maybe this isn't really about your students. Maybe you just as yourself want to learn more about computer programming, and maybe that will filter down into your teaching, but that's not your primary goal. But maybe it is, and maybe you'd like to be empowered to introduce programming to your students. It's also possible that you're unsure of how programming is relevant outside of tech-specific work, how computational thinking can be applied without a keyboard or without writing lines of code. So let me tell you a little bit about me. So my name is Michael Taggart. I'm the technology director for Merman School for Gifted Children in Los Angeles. I teach computer science there as part of my responsibilities. But before I did that, I taught English. And my mom was an English teacher. I majored in English in college. And I didn't really think that I was going to become the evangelist for programming in schools until I started working as a technology specialist in independent schools. I taught myself all the tech skills that I know. And that to me has given me a certain perspective on the learning of these skills, because I've had to cobble together the methods that work. They weren't given to me. And I've been doing this since 2011. we're going to embark on learning our first programming language. I say first because it probably won't be our last, not even in this series. My hope is to cover a number of languages to give everyone who's participating exposure to different kinds of ideas in programming. Not all languages are created equal, and some are better at different jobs, some operate in different domains. And also, once you learn your first programming language, your second language is much easier to learn. It's a little bit different than learning human languages or foreign languages in that regard. Maybe that gets a little bit easier, but the degree to which your second language in programming is easier than the first is monumental, because you have kind of a model for how programming concepts work. So we're going to use Python as our first programming language. Why? So Python has clean syntax, not a lot of curly braces or semicolons that are going to mess up our work. We're going to focus on the ideas of programming, not so much the typing. Python's also a pretty diverse ecosystem. It has an excellent library of modules. So we can use these modules for things like graphing or data analysis, probabilities, even graphics in games if we decide to go in that direction. Python has carved itself out as a popular language in both academia and industry. Some of the most advanced stuff going on in artificial intelligence is going on in Python right now. Lastly, and this is a bit of a technical point which we're going to explain more later, Python is interpreted rather than compiled. Bottom line right now, what that means for us is that it's going to be really easy to go back and fix our code. That pipeline is faster than if it were a compiled language. So what will we be using for learning Python? So we're going to use two things. The first is going to be Replit, or repl.it. And this is an online coding environment, so we don't have to download anything. I actually use it to teach classes at Mermin. You can create a classroom set of assignments and enroll students. We won't be using it exactly that way because we'll be doing demos here, and I really am not interested in grading your work at the moment. And then later we're going to download the python.org version of Python when we're ready to move beyond what Replit can do. But I want to definitely focus on Replit for right now. One of the big reasons is that Replit will work on any internet-connected device, generally speaking. And for those of you who have Chromebooks in your classrooms, which statistically would be a lot of you, that's going to be huge. So we don't have to download anything or really sign up for anything too onerous. So if you're ready for your first introductory lesson, we're going to get started in our next video. Thank you for watching, and I hope you stick around.